Hey guys, welcome back. Today we are finishing up Unit 6, which is all about acids, bases, and solutions. And today we are learning about molarity and dilutions. So there is going to be a little bit of math involved, but it's just basic algebraic problems. So hopefully it won't be too confusing. So let's go ahead and jump into it. So if we take a look at this image on the screen, we have two different cups of tea here. And before moving forward, just pause and ask yourself, what is the difference between these two cups of tea? So what difference can you observe in these teacups? Well, if we're taking a look, obviously the tea on the left-hand side is darker and the tea on the right-hand side is lighter. So this tea has a stronger concentration of tea. Okay, so in comparison to the water, this concentration would be higher. Now, in, normal terms, you could say, oh, the tea on the left is stronger. This could also apply to coffee as well. Like a stronger coffee has more coffee grounds to water ratio. But we never use the term strong and weak to describe solution concentrations, okay? Because we're chemists, we're scientists here. So instead, we're going to use the terms concentrated and dilute or diluted. Okay, so on the left, this would be a concentrated solution, and on the right, this would be a dilute solution. So the more solute you have per solvent, the more concentrated your solution is going to be. Okay, concentration is just a measure of the amount of solute dissolved in a certain amount of solvent. So a concentrated solution has a large amount of solute. So in that picture we just saw, it would be the darker tea. And a dilute solution has a small amount of solute, so it's that lighter tea that was on the right-hand side. So now we have to talk about this idea of molarity. And you guys know what a mole is, right? We've been through stoichiometry, so we know the mole. But molarity is the measurement of the concentration of a solution, okay? And the formula we're going to use is right here on the bottom in this yellow box. So molarity is equal to the moles of solute over liters of solvent. Okay, so the moles of the solute over the liters of the solvent. Now for molarity problems, most of the time you'll be given the moles. Okay, so you won't have to solve for the moles, but you should be able to because we've been through Stoic. Okay, so you should know how to solve for the moles, but in most of these molarity problems, because we're moving on to solutions, you'll be given the moles. So molarity is equal to moles of solute per liter of solvent. Okay, so of course the unit is just in moles per liter. We can also use something called a molarity triangle to solve molarity problems. And we use this basically just to help us identify when we should be multiplying, when we should be dividing, because if you're given two variables, you can solve for a third one. So this triangle is basically just showing us the different equations that we can use to solve for molarity. So we know that molarity is equal to the moles over volume. So if you see like the unit on top, so this would represent like a fraction, and then if they're next to each other, you would multiply. So it can be a little bit confusing. That's why if you're savvy with algebra, you can just use the molarity is equal to moles over volume. And if you're trying to solve for molarity or volume, you just plug it in and solve it algebraically. But this little triangle can help us. So for example, like if we wanted to solve for volume, let's say we wanted to solve for volume. So volume would be equal to moles over molarity. So like if the problem gave you moles and molarity and you wanted to find volume, we could just use this triangle because again, this line right here represents a fraction and that would give us our volume. So volume would be equal to moles over molarity. If we wanted to solve for moles, then we would do molarity times volume. So these two next to each other would be multiplied together to give us our moles, okay? Again, it's a way to visualize it, so what kind of formula you need, but you can always just use the standard molarity formula, which is molarity is equal to moles over volume, okay? So if they're side by side, you multiply them. If they're on the top and the bottom, you divide them, Okay, and that's just the general rule for the molarity triangle. And if you want to use your molarity triangle to help you, so like if you're not algebraically savvy and you can't just recognize how to plug them in to that original equation, you can watch this video that's embedded in the slideshow, which of course you guys have access to. All right, so now let's do a problem. It says if 2 moles of sodium chloride are dissolved in 1 liter of water, what is the molarity of the solution? Okay, so this is how we can use our molarity triangle. So we are looking for molarity, okay? So we're solving for molarity, which means our equation, we're going to have molarity is equal to moles over volume. Okay, so we're going to divide our moles by our volume here. So 2 is what we're going to put on top because we have 2 moles of the sodium chloride divided by 1 liter, and that will give us our answer. Okay, so our molarity is equal to 2 moles divided by 1 liter, and our molarity is 2 molar. Okay, so we can say molar with a capital M, and that just means moles over liter. So you don't have to write moles over liters for molarity. It's just a big capital M. So 2M is 2 molar. That's assumed mole over liter. So the molarity here is just 2M. Okay, so 2M is going to be our answer. Okay, that's our molarity. Pretty simple. And again, this is an example where the moles have already been given to you. All right, so now how many liters are in 20 moles of a 3.2 molar solution? So here it's a little bit different. We've been given our molarity, right? So we have our molarity, and we've been given our moles, and we want to know how many liters. And remember, liters is a volume unit, so we're solving for volume. Okay, we got to solve for our volume. So our volume is going to be equal to our moles over our molarity. This is how we can use this triangle. So moles over molarity will give us our volume. So if we just plug that in, our volume is equal to our 20 moles divided by our 3.2 molar solution. Okay, again, that's how we can use our triangle to help us solve. So 20 divided by 3.2 is 6.25 liters. So our volume is 6.25. That means there's 6.25 liters in a 3.2 molar solution. And this could be any substance. It didn't tell us what the compound was. So let's do another one. Let's solve for moles. So how many moles are needed to produce a 5.7 liter sample with a molarity of 9.5 moles per liters or molar? So this is an example where we have our molarity and we have our volume, and now we're solving for moles. Okay, since we're solving for moles, we're looking at our molarity and our volume. Because they're next to each other in the triangle, we are going to multiply. Okay, so our moles are going to be equal to our molarity times our volume. So our moles, or our molarity, is 9.545 times 5.7 liters. If we plug that into a calculator, that will give us 53.87 moles. Okay, so that is how to solve that problem. So those are 3 examples of the different ways that you could solve for molarity. You could be asked to solve for the molarity itself, which is the concentration. You could be asked to solve for the moles or the volume. So now you have 3 examples of how to do each of those, and you can always use your triangle, or you could just use that standard equation, which is molarity is equal to moles over volume. Okay. So now let's talk about dilutions, and we're going to do this quickly. What do you do if your sweet tea is too sweet? So if you go somewhere, you get a sweet tea, you drink it, you realize there's way too much sugar in it, you can add water to it and you can dilute it to make it more palatable, right? So a dilution is when you increase the amount of solvent in a solution. And remember, 9 times out of 10, the solvent is going to be water, that universal solvent. So we refer to this process as water it down, right? So if you water something down, you're adding more water to it. A lot of parents do it with juice. So like if juice is too sweet for their kiddos or their toddlers, they'll add water to it to kind of cut down on the sugar. Okay. Now there is a formula for dilution, so we can figure out how much is needed to dilute a substance, and we can change the volume. Okay, changing the volume will change the molarity, because molarity, remember, is dependent on the volume of a solution. And this is the formula we will use for dilution. So it's M1, so molarity, V1, volume, is equal to M2, V2. So M1 is going to be your molarity of your first solution. V1 will be the volume of your first solution. M2 will be the molarity of the second solution. And V2 will be the volume of the second solution. Okay? So those are the starting concentrations and volumes, M1 and V1, and then M2 and V2 are the final concentrations. Okay? If you need help with dilution videos or dilution problems, there's a video embedded in these slides that you can watch. Okay? But let's take a look at some examples here together. So if a 2 liter of a 2.5 molar solution is increased to 5 liters, what is the new molarity? Now, just with stoichiometry, when you're doing dilution problems, it's a good thing to write out what you know, okay? So what is our M1, our V1, our M2, and our V2? Our M1, so our first molarity, is 2.5 molars, okay? So 2.5 molar is our first molarity. Our first volume is 2, so 2.0 is our first volume. We're looking for the new molarity, so we're looking for M2. And our new volume is 5 liters. Okay, so 5 liters is what we're looking for. Okay, so if we plug this in, 2.5 is our M1 times 2, which is our V1, will be equal to 5 liters times M2, which is what we're solving for. Okay, 2.5 times 2 gives us 5. 5 is equal to 5 liters times molarity 2. 5 divided by 5 equals 1. Okay, so 1 molar is the molarity of our second solution. Okay, so this is just a plug and chug. The difficulties here come in when kind of the wording of the problem. Sometimes it can be a little bit tricky to identify what's the M1, V1, what's the M2, V2. You just have to pay attention to the wording, and you guys are going to do some practice today in your study guide. So if you have trouble with this, of course, always let me know, and I'll be more than happy to help. But really, it's just plug and chug. All of these are plug and chug into the formulas. You're not going to see anything that's off the wall. Everything you need are in these formulas. So remember, molarity is equal to your moles over your volume, and then your dilutions, M1, V1 is equal to M2, V2. Now, for molarity, your volume has to be in liters. So the first problems that we did, those volumes have to be in liters. But with dilutions, it doesn't have to be in liters. It can be in milliliters as well. So if you see a dilution problem and the units are in milliliters, that's okay, as long as you're solving in milliliters as well. So you don't have to do any conversions as long as both volumes are in milliliters. So you could see dilutions in both milliliters or liters, but for molarity, it has to be in liters. Okay? All right, so that was pretty quick. That's your final lesson. You guys are going to do some of these practice problems today, like I said. But if you need help or have confusion, of course, let me know, and I'll be more than happy to help you.